first line of energy efficiency is to caulk. Where you caulk around what we recommend and what we found out over at Mishawaka, the test, we ran air tests there a week, or what, 3 or 4 days ago.
Yes.
We ran air tests. They came in on 3 different windows and did the air test, and it was a very interesting result. We found that the air, first of all, when you test a window, you close it off in a chamber, and then you hook up your hose to it, your vent, and then you calibrate with gauges how much air is escaping once you build the pressure up. And they build it up to 1.57 pounds per square foot rather, which is a 25-mile-per-hour wind equivalent. And then they check and see how much of that escapes after they get it built up. And what happened, they tested all the windows as they were installed. Then they went back and they retested it to see how much air was coming in around the perimeter casings. That was a separate test they ran. And they found that the air coming in around those was like 30, 40, 50 cubic feet of air per minute just around the casings. And we had gone through earlier, John had, and caulked up all the interior. And you think that all the air is coming in around the exterior. And the exteriors had been sealed by the windows when they were originally put in, when you put in the mock-up and the 2 other companies did. They sealed the exterior, but they didn't seal the interior. And the interior around, in other words, this is an interior part of the window right here. The part of the casing that goes up against the plaster, this part basically, right along here, right along the plaster line, was a tremendous amount of air leakage coming in. So when if you go to caulk your windows, and I would use a latex on it, which is another type of caulking I didn't talk much about because we don't use it on exteriors. But on the interior, it's perfect because it goes up against the plaster, it dries rather quickly, and it can be painted over easily. And if that line is sealed there, if you have natural wood, I'd go to a clear sealant on it. If this wood is painted, then just go to one that comes the closest to the paint, and then you may want to paint over it afterwards. But you can cut an awful lot of air out just by going around here. Then on the outside of the window, where you have your brick mold, do the same thing, only if you have siding going up against it, or if there's many times brick on a commercial building, your brick will stick out here. Get that sealed around against the brick, and you can cut out an awfully lot of air infiltration just by sealing that off. And then beyond that point is when the window itself, however you weather strip it, whatever you do with it in restoration will make a difference. And we found, interestingly enough, one of the we had 3 windows in a row on the job. I've never seen that done. I've seen testing done, we were doing it 55 years ago in the field. I've never seen it done quite like this. This was a perfect opportunity to check different applications. They ran 12 different tests. And there were 4 windows in a single bay of windows, had a common header across the top of them. And then each window had casings down with about that much plaster between each window, but they were pretty much a common opening that they were put into. And initially, all the windows were sealed off by the manufacturers, or by the people like ourselves, and the window who put in the new window were all sealed by them. But what happened on the application was that they wanted to test the original window. Originally, they weren't going to do that. They were only going to test 3 windows, the 3 new ones that were put in, the 2 restored and 1 new. But they decided they would test the 4th window somewhere along the line. So when they tested it, the 4th window had nothing done to it. It was absolutely original. The only thing that did get done before we knew they were going to test it is that you caulked the interior on that one. Yep. But the exterior, nothing was done to it. It was an original window, no restoration, no weather stripping. It came out 2.3 times looser, more air, 2.3 times more air infiltration on that particular window than the typical restored window was. So by weather stripping it, by restoring it, putting the window back in good shape, was 2.3 times better as far as the amount of air infiltration. which I've never seen that tested before, where all three windows were identical windows size-wise. So the new window also came out comparable with the restored windows. All of them ran very, very close. But the restored, the one we put in, there was a 4-point difference in it, like 4 cubic feet of air difference. We had a couple things that weren't done on the other. We had open weep holes on ours, and normally in a test, those should be left open, but very often they're closed, and we left ours open on it, and that would have made the difference. That came through the pulley pocket, this pocket right up here, which is the weak spot in an existing window, an existing double hung, historic double hung. The pulley pocket is where there is air coming up through the wall of the building, up through the inner width of the building, the cavity in the wall, and it comes out through the pulley pocket. And we were amazed that we got that close to it within 4 cubic feet to a brand new one, because a brand new window is like this. There's no pulley pocket. It's just a solid piece of wood. And so we came within 4 cubic feet of air with the pulley pocket. And we have a cover that we make for these that we could have put on and we didn't. We left it off. Just we wanted to see how they compared without it. But we found out that 4 cubic feet of difference by covering the pulley pocket. We could have probably would have had a better rating when in fact the pocket was covered in the first test they ran. They taped it up to see just what it would do. And when that happened, we had 92 cubic feet of air leakage on the window. Then when we took the tape off, we had 102 cubic feet of air, so you had 10 cubic feet of air difference. The new window had 98 cubic feet, just as it stood. So we were, with the pulley pocket cover, like our cover does that we have, it was down to 92 and 98 for the new one. So when they talk about how much more energy retrofit an existing window is, and that's what they all advertise. They come to your house or they'll try to sell you on the idea, we'll cut 1/3 of your heat loss if you put our new windows in. That's not true. That's not true. The funny part about that is many of you or some of you may have windows that are painted shut right now. And there's no better insulation or glue than paint. You try to move a window that's been painted shut, you're not going to, and air is not going to get in it. And then we run into, when I was on the Historic District Commission, and people would come and say, well, we want to save energy. One of the first questions I asked, do you have storm windows on? Yes. What kind? Wood. Okay. Do your windows operate? No, they don't operate. They're painted shut. If they tear those out and put in a new vinyl replacement window or even a new wood window, you're going to have more air leakage than you had with your old window, because the old window was absolutely sealed up from air. There was no air coming in around it. And you're going to have air coming through any window that operates. It's just a matter of degree. How much are you going to have? Some are many times tighter than others, right? We've run into wood windows where I've seen tests run that the one wood window would have an air infiltration of 0.01 cubic feet of air per minute. The window right beside it would have an air infiltration of 3. So, and 4 even, 4.5 as opposed to 0.01. And they're new windows. So there is a difference in the new windows, but I don't care what kind of a window, if it's operating, if it's fixed, that's another story. A fixed window or stationary window is usually sealed in. And so there you're not going to get air usually. But anything that operates, you're going to have air coming in. So if you tear out a window that's painted shut, that has a storm window on it, your U value with that storm window is as good as the U value of insulated glass. So you're not gaining anything on U value, but what you did have with your old window is an airtight window, and your new one's not going to be. So when these salesmen, the broad statements will save you 30, 35% in your fuel, that's all wishful thinking. It doesn't happen that way. In weather stripping, the older windows probably had none. Maybe your house had no weather stripping in it. And then around 1910, 1915, the weather stripping business became a very major factor in the window business. And all these people did was put weather stripping in, and they used a lot of the metal weather strip. It's still made today. This happens to be one made out of bronze. They're made out of zinc and out of aluminum. And these fit in the track, and they put a route in the sash so that it slides up and down on the sash slides up and down on it. And this has been accepted as probably the premier type of weather stripping over the years, but the only problem, well, it has a couple problems. One of the problems is that when they put the route in it, the route in the wood has to be larger than this leg right here, or it doesn't slide. You can't make it real tight. And as a result, the air coming in around this leg right here infiltrates, and it doesn't really make a terribly tight seal. What it does do is help against a gust of wind when you get gusty wind, but just sitting there during the winter, air is working its way around here. They've, in recent years, gone to silicones, to vinyl bulb gaskets. This is a Santoprene one that sticks on, and we don't recommend the stick-on ones because they don't really hold well. This is the one we've used for, oh man, probably 40 years anyway, and maybe close to 50 years. This was developed by the Pullman Railroad Company, or for them, and they used them on the windows. You've seen it in your cars also. It's a woven pile material, extremely flexible, and it seals up against the window like on here. It's in the stop here. It's in the stop outside, so it gets to the upper sash. This is all sealed here. We put it in at the meeting rail, so it's sealed here, which is where a great deal of the heat loss is and air infiltration is at this point right here. It's also at the head and at the bottom. So the window is really sealed up as well or better than any of your new ones, and it's in a window that's close to 100 years old or 70 years old. And it can be done on any window. We just put some in out here at the school in Mishawaka. We restored a window there and used it. When the test came back, it was virtually, you might say, almost a tie with the new wood window. It was about 20% better than what the one was that the metal weather stripping was used in. But the weather strip in the woven pile is the most durable. This will last. Well, I saw it first in a hospital where it was built in 1944. It was still in there when I saw the job 45, 50 years later. It's extremely durable. On my own home, I had an oak threshold that those vinyl bulbs, you know, that are on the thresholds, kept popping out. And so I routed it out, and we put this in it, the woven pile, and it's still working 20 years later. You're walking over it, and it still works. It's extremely durable. Now, there's two types of it. One that slides into a T-slot like this, and one that is put into a slot, which this one has right here. And this is something that any homeowner can do. You just take your saw and run it down your stop, and then the pile has a kerf in it right here that slips into it. Energy retrofit. This has always been a question on windows and historic windows. How do you seal these up so that they are comparable? One is with weather stripping. There are other options. There are glass options where you can put a panel on your sash. The sash can be routed out and a panel made. You route this out here on your existing sash, and a storm panel put in. This is typically what they call a double glazed sash. This rides with the sash. It's a storm window in effect, but it's not on the complete exterior of the window. It rides up and down with the sash itself. Then you can get into insulated glass, and I'll cover that. This, for those of you who are not familiar with what insulated glass is two panes of glass put up against a metal spacer with sealants that go around the exterior perimeter of it. And on a dual seal, they also put an extra sealant along the edge against the metal, so the glass goes in against it, and then they seal the exterior. The dual seal will give you many more years of wear, but not a lot more as far as overall. When you look at a piece of glass, single glazing in a window, It is the most durable product made by man, probably. If you can think of anything that lasts longer than glass, there's probably nothing that man makes. You can take a piece of glass and bury it in the ground, and 3,000 years later, you can pull it up and it's still glass. Insulated glass is another story. The glass may be there, but it's lost its function, and many times within for 5 years, 3 years. We had, when we did Jackson Prison Administration Building a few years ago, they had approximately 60% of them failed within 6 months. This was a system developed by Pella a few years ago, several years ago, and it was very successful. They had to learn their lessons. They had to learn that you had to put weep holes in it or condensation would form and rot the wood. But once they got that solved, the little insert here, it's used with little clips like this that fit in and then push into the pocket. And this gives you a 13/16 inch airspace. But this is also just an insulation for the glass. It does not insulate around the crack. It's only the glass area. But it's a better solution than insulated glass. The U value actually is better because your airspace is deeper. And it's a better solution because you don't ever have to worry about throwing the glass out. If condensation forms, take the panel out, wash it off, and put it back in. So this is one of the solutions, or short of going to insulated glass. But the best solution is a storm window. A storm window covers the whole frame of the window. So it's not just the glass area. You're sealing up the crack around the window. And by sealing up that crack, you're solving both problems. You have the double glass with a 2 to 2.5 to 3 inch airspace, which is far better than a 1/4 inch of airspace that you get with this. So your U value is much better, plus the fact you're sealing up the air infiltration around it. Now there are various types of storm windows. There's ones like this that build out. This is the lowest common denominator of a storm window. We're replacing this type all the time for several reasons. It's not a particularly tight application and is not very durable because of the way they're built. As an example, the extrusions that they're in, that this type of window has, many times are like this, a little nylon corner key that has little pins here that turn, and it's just nylon. Whereas the better storm windows use keys like this that are either extruded or stainless steel keys. And that's the reason that some storm windows we put on have 50-year lives without any problem, 50, 60 years. In fact, one brand we use, I haven't seen any of them fail. We were putting them in 1949 we started, or 59 rather. We started using them, and they still have held up because of the components within the storm window. And that's this type right here. It's what's in that window over there. It's a box frame expander. This can be expanded in or out so that it fits. If the window's out of square at all, which you get into 100-year-old windows, sometimes they're out of square. And this can be moved in or out so it fits snug up against the wall. And when it's in, it gives a flush appearance to the wall, to the window. It looks like a wood storm window. A couple of examples. We did the Livingston County Courthouse with these in black because the old wood storm windows were black. And when we were doing it, you stood in front of a building. We had ones on the the left side in, and we were working on, and on the right side as you face the building were the old wood ones. And standing from here to those chairs, you couldn't tell which one was the wood and which one was the aluminum. And ones that John put in up at Gratiot County Courthouse in Ithaca, the architect called me the day after we started the job. He said, "I understand you started this job yesterday." I said, "Yes." He said, "I'm going up and see it." He got up there and called me. He said, "I don't see any windows in." And I said, "Look, where are you?" And you were up above on the scaffold. And he was looking at windows that we had put in that day. Didn't even know they were the new storm windows that were on there. So they do blend in. They look like a wood storm window because they're a flush face. They're not a protruding unit. And not only that, they are extremely airtight. They have the tightest ratings of any window in the industry, both for air and for acoustics. But the storm window is the answer that's the best answer. There are adaptations with this window. Where this is the normal window right here, there are adaptations such as if it's a building with a particular type of brick mold, they have this, that this window fits inside of. This is the basic window. And this goes down over the sill, covers up against the brick. And usually in residential use, this isn't used. But you take commercial buildings where they have 100 windows, 200 windows, it's a brick building. This is a practical answer. It may not be as purist, but the nice thing about it is reversible. And that's the other thing with the storm window, it's reversible. You're not damaging the window when you put it in. This is another one. It's what they call a panning system. This is one that we're using at Mishawaka that we have there. It's coved, and if you look at this window and look at the wood window next to it that does not have a storm window on, it's very difficult to tell that this is not the wood brick mold that's on there. It's almost identical to it. And this is a standard historic one that we have. And this, of course, can be cut off to the depth of the sill. This hangs down farther. This was originally designed for one that had transoms and a mullion between, and this was part of a cover system for it. But this is the same basic storm window that you're looking at right here, except it has the panning cover on. But storm windows give you the U value that you want. They're better than the U value on insulated glass by usually between 10 and 15%. And it gives you the protection from air infiltration.